All right. Good morning, everybody. Let's go ahead and let's get started. Let me start my timer here really quickly. And what I'd like to do this morning is I want to go ahead and I want to start kind of in a similar way that we started out yesterday, where I'm going to ask you to do a problem from the problem set. So let's go ahead and let's take a look at number 5 from your problem set. I really do want to make sure that you understand the importance of being able to identify the correct ion for a particular element, just so that we can then use that to come up with the formulas, which is what we'll be doing today. And so let's go ahead and let's do this here on number 5 from your problem set, from the chapter 9 problem set. What I'd like to do then, they're asking you to name the ions, okay? So the ion that forms. I would like you to write out the symbol for the ion that forms for these three elements here. Write out the symbol, and then I'd like you to write out their name, and then go ahead and then classify them at that point then as cations or anions. So please do those three things for number 5 from the problem set for chapter 9. Okay, so let me go ahead and make note of that. Let's go ahead then and let's four. Yep. Go ahead, take about a minute. I hope it shouldn't take you that long. Take about a minute to work on this here, and then we'll go over together. Okay, so go ahead, get started with that. Okay, let's take a look at this here. I'm going to go ahead and open up my whiteboard here. Go ahead and let's open whiteboard. Give me an opportunity to share this with you and work this out with you. Okay, so let me go ahead and open that up. Okay, let's see. Okay, all right. So let's go ahead and take a look at this. So the first element that we are given is a metalloid. Okay. Now we did talk about that yesterday. So selenium is a metalloid, and so let's go ahead and this is going to be number 5 from the chapter 9 problem set. Okay. All right. So the very first element that we're given is the selenium. Okay, and it is a metalloid. Now, metalloids, we said yesterday then, and we want to make sure we keep in mind, it is capable of behaving both as a metal and a non-metal. It can do both. Now, when metalloids become part of a compound, and they do, they typically actually form what are called covalent bonds, and we'll talk about that in chapter 8. So we'll typically see then metalloids behaving as non-metals, and so we'll see that, but they will be engaging in bonds that are not ionic. However, every once in a while, very rarely, you will see a metalloid participate in an ionic bond. That is, it is part of an ionic compound. When we see that, it also, for the most part, and very rarely, and I haven't really seen any in my experience, metalloids behaving as a metal and forming cations. Metalloids tend, when they form compounds, to behave more like a non-metal than they would a metal. Okay, so with selenium, then, if selenium then is going to form a non-metal, if it's going to behave like a non-metal, it's going to form an ion, and it's going to form an ion that's going to be an anion. Okay, and so the anion then, if you take a look at selenium, it is underneath. It's in group 6A. Okay, it's in group 6A, and like the other 6A elements, like oxygen or sulfur, it's going to have then. It's going to gain 2 electrons and form a negative charge. Okay, so therefore, the symbol for selenium, the selenium ion, then it's going to be Se with a 2 minus charge. Okay, so the reason for this again then is that it is also a 6A element. So it's underneath sulfur, underneath oxygen. And remember, elements within a group will behave very much the same way. So if oxygen, if sulfur, if both of those are going to gain 2 electrons to form an anion, so will selenium. So again, selenium is a metalloid. It's not a non-metal like sulfur and oxygen, but it will behave like sulfur and oxygen when it becomes an ion. Okay, so there it is. There then would be the symbol for the ion that forms from the selenium atom. Okay. All right, so with that said, then I did ask you to name this particular ion as well. And so with this then, remember with an anion, what you want to do is you want to add the suffix IDE. Okay? Now that means then you have to drop a portion of its name. And with most of these here, you will just basically have to memorize their names, unfortunately. But with these monatomic ions here, their names end up being fairly straightforward. Again, it just takes a little bit of practice and you'll get this. But then this ends up being the selenide ion or the selenide anion. Okay, so we're going to we drop the IUM and we add in the IDE. Okay, so that's the name of the compound. I'm sorry, the name of the ion right there. Okay. All right, let's go ahead. Let's take a look at the next one, barium. Okay. So if selenium is a not is a metalloid that behaves as a non-metal, barium is obviously a metal. Barium is a metal, and it is a representative metal. It's a 2A metal, which makes things a little bit easier for us, which means that it will lose 2 electrons, and it will achieve a charge of 2 plus. So that's going to be the formula for the barium ion. Okay. And to name this particular ion, then we just go ahead and we write down the name of the metal itself and the word ion or cation. So that is the barium cation. Okay. All right, finally, phosphorus. Phosphorus, phosphorus is an example of a nonmetal. Okay, and all nonmetals, remember, they will form anions. Okay, and they will and phosphorus then is a 5A. It's a 5A nonmetal, and so therefore it will gain 3 electrons in order to achieve its octet. Okay, and so with phosphorus, then we're going to drop the last 5 letters here, and then we're going to add in the IDE. So this ends up being the phosphide anion. Okay. All right. So what we have here then is we have then a group of monatomic ions. So these are monatomic ions here because they are made up of single atoms. These are monatomic ions, and you got to keep this in mind because what we're going to do today is we're going to try to finish out with chapter 9 and talk about the polyatomic ions and how they're different. I had a chance to discuss this with a couple of you yesterday, which is good that you asked about this. And so just make sure you keep this in mind that what we've described here then are the monatomic ions. And again, monatomic because they are made up of a single atom. So we see then now an example of the 3 different types of elements and what they do. So we have here our metalloid, and we see then that the metalloid forms an anion. We have here a metal, and we see that it forms a cation. And then here we have the non-metal, and it also forms an anion. Okay, so we have an example then of 1 cation and 2 anions that form from these neutral atoms here. Okay? So make sure you keep that in mind. What you need to be able to do then, and this is going to be critical, you have to make sure then that you are able to determine then the the symbols for each one of these ions that form, because that's going to be critical in what we'll be doing in just a moment. Okay, so please make sure you come by and you see me if you have any questions on this, and then I'll go ahead and save this, and then we'll go over together. But let's go ahead then and let's pick up with where we left off with yesterday. Okay, so what we talked about yesterday, let me go ahead and share with you my screen here really quickly. Let me open up another screen for us. Okay, all right. So yesterday we were talking about how we name binary compounds. Okay? And so we went and we went through quite a few examples of what binary compounds are. So let's quickly review that. And I don't want to spend too much time, but we spent a lot of time on that yesterday. But let's quickly review. Binary compounds are compounds, and understand we will we will revisit this idea of binary compounds when we get to chapter 8 and we talk about the covalent compounds. But the general definition of a binary compound is a compound that's made up of 2 elements, not 2 atoms. It's very tempting to remember. Try to remember a binary compound is just a compound made up of 2 atoms. That's not the case. It's an element. It's a compound that's made up of 2 different elements. Okay? And that may mean more than 2 atoms, but 2 different elements. Okay, and so that's the general definition of binary compound. We're applying that term now to ionic compounds, and so we are dealing with binary ionic compounds, which means then with binary ionic compounds, we're going to have 2 elements. We're going to have an element that is going to be a metal, an element that's going to be a non-metal. So those two elements get together and they form then this binary ionic compound. So we are now focusing, we're more specific, and we're looking at the ionic compound that are made up of only 2 elements. Okay, so that's what a binary ionic compound is all about. So once you've identified then that it's a binary compound, the naming process becomes pretty simple, because what you have to do then is you're going to name the metal, the cation, and you're going to name the non-metal, the anion. And then you're going to drop the word ion, and then you're going to go ahead and obtain the name that way. Okay? Right. Keeping in mind, though, that if you have of a metal that is a transition metal or one of the four representative metals that require the use of the stock system, then you have to use the stock system to name the cation. So you got to be mindful of that as you go through this. Okay, so I'm going to be going through. So let's go ahead. Let's take a look at number 13 here in your problem set. And I would like to work this out together with you. I'd like to do this with you to give you some practice. I'll do the first three with you. I'm sorry. I'll do a couple. I'll do a few of these with you, and then I'm going to ask you to do the remaining ones. Okay. All right, so let's go ahead then, and let's take a look at the very first one. Let's take a look at the first one here. And so let me go ahead. I need annotation markers here. Let me go ahead and open the markers. Let's go ahead and let's answer the first question in regard to number one here. Okay, so first of all, is this a binary compound? The answer then should be yes, because it's made up of two elements: Na element that has Na, that's sodium, and the element Br, which is bromine. So there it is. This is a binary compound. It is made up of two elements, sodium and bromine. Second question, is this an ionic compound? And the answer then also is yes. Why? Because sodium is a metal and bromine is a nonmetal. So this is an example of an ionic binary compound. And make sure you keep this in mind that we are dealing with ionic binary compounds. Ionic because the bond that holds these two together is going to be ionic. Okay, binary because you only have two elements. So these are all, if you notice, these should all be binary ionic compounds, or else I wouldn't put them in here for you. Okay, all right. So with that said, we have that. So we want to be able to name this particular compound here. We want to be able to name this particular compound. So what do we have to do? We're going to go ahead then, and we're going to write out the names of each one of the ions. Okay, so the cation, this one is going to be sodium. So let's go ahead and write down that. It's going to be the sodium cation. Okay, and the anion then is going to be bromine, but it's an anion. So make sure you modify that. So this is going to be the bromine anion, which we refer to as the bromide anion. Okay, all right. So when we go to name this compound here, remember what we're going to do then is we're going to drop the last part of the name, and then we end up with write down whatever's left over, and then we will have the name of the compound. So what's left over then? Let's go ahead and write this down. Okay, we have then sodium bromide. Right, and that is the name of this compound. Pretty straightforward. Hopefully not that difficult. Okay. All right, so let's get down to number 4 here. Okay, and let's do the same thing. Okay. All right, so with that said then, is this a binary compound? Yes, it is. It's made up of Cu, which is copper, and oxygen, which is another element. Okay, so we have then a binary compound. Is this an ionic binary compound? Yes, because the first element is a metal, the second element is a nonmetal. Okay, so this is a binary ionic compound. We can go ahead and name this very straightforward. We're going to write down the name of the cation, which is going to be copper. Okay, so it is the copper cation. Okay. Okay. And the name of the anion then is going to be the anion from oxygen, which is going to be the oxide anion. Okay. All right. And then before we finish up and write the name here, we have to make sure we include the Roman numeral here. Why? Because copper is a transition metal. We did not have to do it here with sodium because sodium is not a transition metal, and it's not one of the four. It is not tin, it is not lead, it's not bismuth, it's not antimony. So if it's not one those four representative metals, you have to use the stock system to name. Okay? So sodium is not any one of those, and so we don't need to use the stock system. We don't need to include the Roman numeral. But with copper, we do. This copper is a transition metal. And so the question then is, how do we determine then what the charge is? Remember, the Roman numeral here will indicate the charge on this copper. Okay, so how do we go about determining the charge on that copper? Well, what we have to be able to do then is we have to determine the charge on the anion first, okay? And recognize then how many of each one of those atoms we have. We have one copper atom in this particular compound. We have one copper atom and one oxygen atom. Okay? So what you want to do then is let's go ahead and let's write out the the symbol, and this is why I wanted to start with this today, and this is why we spent a whole lot of time yesterday talking about coming up with the symbol, talking about how we get the symbol for each one of these ions here. Okay, so let's write out the symbol for the oxide anion. The symbol for the oxide anion is O2 minus. Okay, that's O2 minus. Okay, and if you notice here, we have one O2 minus. And remember, if there's no subscript, that indicates that there's one. Okay, that means then we also have one copper. So we have one copper. Now remember, whatever the charge is here on copper, when you add those together, you have to end up with a net charge of 0. Okay, so hopefully you can see here, and hopefully at some point you'll be able to do this in your head, folks. But I hope you see here then that if you have one copper, it must have a 2+ charge in order to cancel out, or in order to cancel out the 2 negatives here. Okay, and only when you have that do you end up with a net charge of 0. So that is how we determine then the charge on copper. And now we know then in this in the parentheses here, we're going to include the Roman numeral 2. Okay. And you have to be able to do that. You got to be able to get the charges here in order to get that. Okay. So with that said, then once we have that, the rest of it's going to be pretty straightforward. To write down the name of the compound that forms from these two ions in, what do? We drop the word cation, we drop the word anion, we write down whatever's left over. So this is going to be then copper 2 oxide. Okay, so copper 2 oxide, that's the name of that particular compound. Okay, all right. What I would like you to do now then is I would like you to try numbers 2, 3, and 5. So I did 1 and 4 for you. Let's do 2, 3, and 5. And then what I would like to do then is I'll go over this with you. Let's take about 2 minutes. Let's do this again. Let's take about 2 minutes in order to get this done. And then I would like to go over this with you. Okay, so go ahead and let me save this for you. And then let's go ahead and let me close it. I'll leave this up on, okay. And so let's go ahead then and let's work on the remaining 3, name the last 3 compounds here. Okay. Okay. Hope you had a chance to work this out, folks. So let me go ahead and clear up the screen here. Okay. And let's go ahead and let's take a look at the next compound here. So number 2. Is this an ionic compound? Hopefully you recognize that it is. Again, it's made up of 2 elements. Remember, not 2 atoms. This is 2 elements here. So this is going to be cesium is the first element and oxygen is the second element. This is a binary compound. Is this an ionic compound? Is this an ionic binary compound? And the answer is also yes. The cesium is a metal, oxygen is a non-metal. So this is an ionic binary compound. Okay. All right, so let's go ahead and let's name it. Let's name the cation first. So cesium is the metal, so it becomes a cation. So we're going to write that down. So it's going to be the cesium cation. Okay. And the oxide anion. Okay. All right. Do we need to worry about the Roman numeral here? No. Hopefully you recognize that because cesium is a 1A metal. Cesium is a 1A metal, so you don't have to include the Roman numeral here. So the next step then is we just got to make sure we drop the anion, the cation, and we write down whatever's left over. And we get the name of the compound. Okay, so this is going to be then the cesium oxide. That's the name of that compound. Okay. All right. Very good. Let's go ahead then and let's take a look at the third one. Okay. Let's take a look at this one here. And again, I know that repeating these questions over and over again really takes up a lot of time, but I'd like to, on the front end, remind you of these questions so that at some point you're just asking yourself unconsciously or subconsciously these questions and be able to get to it. So the hope then is that you don't have to go through all this, that you can go straight from the formula here and get straight to the name. Okay? At some point you have to be able to do this. Okay? But until we get to that point, I'm going to continue for the next today's lesson and maybe in tomorrow's. I'm going to continue asking you that question. Okay? So the question here, is this a binary compound? Yes, because you have 2 elements here. Okay, again, you have 3 atoms here, but you have 2 separate elements. Okay, all right. So this is a binary compound. Is it ionic? Yes, because you have a metal and a non-metal atom. So let's go ahead then and let's write out the names of the cation and the name of the cation and the name of the anion. Okay, so The name of the cation then is going to be strontium. Sr is the symbol for strontium. Okay, that's the metal. And then this says it's the cationic form, so we're going to write down the word cation. Okay, the anion then is going to be made up of fluorine that has a charge. That's going to be the fluoride anion. Okay, and hopefully you also see here we do not need to make use of the stock system because strontium is a 2A metal. It's a representative metal, so we do not need the Roman numeral. Let's go ahead and just write down whatever's left over: strontium and fluoride. Okay, and we that is after we just drop the name, the cation, and the anion. Okay. All right, let's take a look at that last one. Let's take a look at that last one. Let's work that out together. Okay, so let's go ahead and again, let's answer the question. Is this a binary compound? Answer is yes, because you have two separate elements here. You have copper and you have oxygen. Okay. All right, so with that said then, is this an ionic compound? The answer also is, again, yes. You have metal and a non-metal. So let's go ahead then and write out the name of the cation, the name of the anion. Because the name of the cation here is going to be copper. Cu is the symbol for copper. This is the copper cation. Okay. The anion then is going to be oxide. This is going to be the oxide anion. Okay. And so with this particular compound, we have to determine then the charge on that copper as well, because copper is a transition metal. So let's take a look at what we have here. We saw in this one, and I'm going to go ahead and write this one out for you again. This was the copper 2 oxide, sorry, the copper 2 oxide. And the reason for that was we were able to determine, and let's go ahead and write this down, that this copper here has a 2+ charge, because the oxide here has a 2- charge. If you only have one of them, okay, that one oxygen has to have a 2+ charge. Okay. Let's go back doing the same thing with this compound here. Again, oxide is a 2-. So let's go ahead and write that down. Always start out with the anion. The anions don't have multiple charges. Okay, so start with the anion and figure out what we have here with the copper. Okay. Now we only have one oxide here. We have 2 coppers. Okay, the subscript here tells us that we have 2 coppers. Remember, that's what we got to keep in mind. So each one of these coppers together, okay, together both of them has to have, and I hope you recognize this, together both of them must have a 2+ charge, okay, because that's the only way we're going to get a zero-sum charge. Okay. That means then each one of these here have to split this positive 2 charge. So hopefully you recognize then that each one of these then will have a +1. So each copper ion is a +1. The name that we put in here is the name of the ion itself. The name of the ion is copper 1. We have 2 of them, but we have 2 copper 1 ions. Okay. So yes, the Roman numeral indicates the charge. It does not indicate how many we have. The little subscript here tells us how many we have. What you have to do with the Roman numeral is you have to indicate the charge on the ion itself. Okay, so each ion here has a +1 charge. Okay. All right, so with that said, then the rest of it's pretty straightforward. I think that's going to be the most difficult part. Okay. The rest of it is, let's just go ahead and write down the name of what we have left over. So I'm sorry, we're going to drop the cation, the term cation, the term anion, and we end up with copper 1 oxide. Okay, so if this is copper 2 oxide, if you notice, copper 2 oxide, the Roman numeral again does not indicate how many of the coppers we have. Here we only have 1 copper. The Roman numeral here is 2. The reason for that, the 2 indicates the charge of the copper, not how many we have. If you take a look at this here, the copper here is copper 1. Again, the Roman numeral 1 does not indicate how many of these coppers we have. It indicates the charge on one of the coppers. And so this is a common mistake made by many students. So please don't you be the one to do that. That they've in the past confused these two and they switched this around because they looked at the number here. Okay. Again, the Roman numeral does not indicate how many of the ions we have. It indicates the charge. Okay, so please make sure you keep that in mind. Okay. All right, very good. Let me go ahead and save this here. Let me go ahead and save this here. Okay, and then let's go ahead then and let's continue on. Okay. Now that we've worked out how to write out the name. So here we're given the formulas. Okay, so we're given the formulas for all these. Okay, we need to be, you need to practice. We should be able to come up with the names of each one of these. What we need to also be able to do, and this is what you got to make sure you keep in mind, is that if you're given the name, can you write out the formulas? Okay, what we have done up to this point is we have been given the formula, we've come up with the name. What we need to be able to do then is if we are given the name, should you be able to come up with the formula? The answer there should be yes. Obviously, it's yes. It was a rhetorical question. I was hoping you get an answer yes out of that. Okay, but how do we go about doing it? Okay, the process is very similar. It's actually basically, if you think about it, it's going to be the reverse process of what we did to get the name. If we're given the formula, we had to follow certain steps to get the name of the compound. Those same steps that we use to get the name, we're basically going to use the reverse. We're going to go backwards. We're going to go backwards to get the formula if we are given the name. Okay, so if we know the name of the binary compound, we need to know how to write out the formula. What we're going to do then is we're going to first of all ask. So actually, we need to make sure we identify that we have a binary compound, that it's ionic. Then once we have that those two questions established, we can go ahead then write down the symbol for the cation and the symbol for the anion. And it's for this very reason, folks, we had to practice this. We spent a lot of time practicing, reviewing this yesterday, and we started out today also with more practice in doing this. And so with that said, then we have to be able to write out the symbols for both the cations and the anions. And this is the critical step here, because if we don't do this step here, you guys, writing out the formula doesn't, we won't be able to, we will not get the right formula. Okay? All right, so once we have that, then what we're going to do then is very similar to what we learned back in chapter 7 last week. Okay? That is, you want to be able to use those subscripts to help you balance out the charges. Okay, so remember, all ionic compounds must have a zero-sum charge. That means the amount of positive charges and the negative charges must balance each other out. We should have the same amount. We should have the same positive as the same negative. Okay? And however we get that, we will get the right formula. The easiest way to get that is basically just to cross those charges, and that I will review with you again. But we did that. Okay, and if we do that, then okay, that will allow us to balance out the charge. So we got to make sure then that we balance out the charge when we before we're at the formula. We got to make sure we balance out the charge again. However you choose to do it, you got to make sure you get that up. You can do that by writing out the formulas and then writing out the number of ions that you need. And in the early steps here, I will early examples here, I will do that for you. But then we want to be able to do this quickly. So I'm going to, by the end of our practice here, I'm just going to be crossing charges. Okay? So I will be using then the crisscross method more often, and hopefully you'll end up doing this too, because you can just do that mentally. Okay, the only thing you want to make sure you do then is that, remember, in the end, you got to make sure then that you obtain the lowest whole number ratios. That's the only thing that you have to be mindful of when you use this crisscross method here. You got to make sure you obtain the lowest whole number ratios. If you don't, then you're going to get the wrong formula. Okay, so that's the only thing you got to be mindful of when you use the crisscross method. Okay? All right, then finally, what you want to do then is make sure then that you do not include any charges in your final formula. Okay? In the final formula, there shouldn't be any charges, because the idea then is that the ions now have come together to form a new compound. They're not separate anymore. If you include in those charges, you're still indicating that they're separate. That's the first thing. Secondly, then we have a neutral compound. So if you write in the charges, there could be the mistaken. It could be mistaken that the compound is still charged. So don't do that. So in your final answer, there should be no charges. So do not include a charge, any of the charges in your final formula. Okay. All right, so that's what you will do. Those are the basic steps that we're going to follow. In a sense, it's kind of do the reverse of the what we did for coming up with the name, but with a little subtle difference. Okay? Let me go ahead and save that. Okay, let's take a look at an example. Okay. All right, the name of the compound, potassium chloride. These are the questions that you want to answer. Again, please don't memorize these questions. Don't use them early on, but don't. You got to get to the point where you don't need to use these at all. Okay. All right. So let's go ahead then And let's answer the questions. Okay. First of all, is this a binary compound? The question is yes, and what you need to make sure you are able to do is from the name, should you be able to identify the binary compound? Given the formula, it was pretty straightforward. You just looked at the symbols. You had two different elements, okay, and so that was pretty easy to see. This is a binary compound as well. Why? Because this is the name of the first element here. That should be simple, folks. That should be simple. Potassium, that is an element. Okay. What's difficult for some folks to see then is that this is also an element. It is the ionic form of the element, but this is chlorine. So this particular compound, the name of this compound is the name, also indicates that it is a binary compound. It's made up of two elements. Okay? Now, second question then, is this an ionic compound? Hopefully you recognize the thing that really you got to recognize then is that this is a metal, potassium is a metal, and chlorine is a non-metal. So yes, this is an ionic compound, which means then we should be able to identify the cation. Okay? So what makes things simple here for us is that the order that they write the name in is also the order that they write the formula in, which always starts out with the cation followed by the anion. Okay, and so the cation here is potassium. Potassium ion, or the potassium cation. That's what we have. Which means then once you identify that, okay, we can write out the symbol. And this is why you have to remember this. Okay, potassium is a 1A metal, and so therefore its symbol then is going to be K plus. If you cannot go from step 2 to step 3, if you don't remember that, you got to practice it more. And if you need to, please come by and get that extra help, because you got to get to this point here. Okay, all right. So let's do the same thing with the anion. The anion then is the chloride anion. Okay, and so basically what we're doing is we're kind of working backwards, and we're identifying the ions now. Okay, so the chloride anion, then the symbol for the chloride anion is going to be Cl minus. And again, if you cannot go from step 4 to step 5 fairly quickly, you got to make sure then that you practice it where you combine C. Okay, all right. Now that we have the cations, we have the anions. The next question then is, okay, if we combine them together, okay, if they come together in a 1-to-1 ratio, if we have just one potassium and one chloride, will the charges balance? Okay, well, let's consider this here. Okay, this is a 1 plus, and this is a 1 minus. If you add those together, do we get 0? The answer there is yes. So therefore, we only need one potassium cation and one chloride anion to balance out the charges. Okay, so that's what we have to do. Okay, now what you could have done, and this is the crisscross method that I was referring to. What you could have done then, and this is what, like I said, I'll be doing later. Okay, that you could take the charge here and move it down here. Take that that 1 and move it down here. So you're not moving the whole charge. You're just moving the number. Okay, and if you do that, then you'll end up with 1 potassium and 1 chloride, which is exactly what we determined up here. Okay, which is exactly what we determined up here. Okay, all right, so we don't have to write in those ones. Those ones are implied. So the formula then for potassium chloride is going to be KCl. As you notice, with our final answer, what do you see not there? We don't see the charges there. So do not include the charges in your final formula. Okay. All right, very good. We go and save this. Let's take a look at another one. Let's see if we can get another one done really quickly. Let's take a look at the this compound here. Okay. All right. So let's go ahead and work through this one, and let's go through all the questions again really quickly, and that way then we'll get a chance to do this again. All right, so is this a binary compound? Yes. Iron and oxygen. Okay. Iron is the metal. Okay. And oxygen is the non-metal. Okay. And so the metal then, so this is a binary compound. The answer there is yes. Okay. The metal then will always be the cation. The name of the metal here, or the name of the cation here is, remember, iron 3. Iron is a transition metal, so it's going to be the iron 3 cation. Okay. Remember, the Roman numeral gives us the charge. So all we have to do then is write down the symbol for iron, because that Roman numeral right there tells us the charge already. It's that simple. As long as you remember that in the stock system, the Roman numeral gives us the charge, that becomes very simple. Okay. All right. So therefore, the anion then is going to be the oxide anion. And again, so to get from step 2 to step 3, that should be very simple as long as you remember what that Roman numeral tells us. But from step 4 to step 5, again, you have to memorize that. If you don't, if you can't, if you don't know how we get that, again, please come by and see. Okay. All right. So the question then is, will the charges balance out? If we have a iron that has a 3+ charge and an oxide that has 2- charge, will they balance out? No, obviously no, because +3 and a -2, that does not equal 0. That gives them, sorry, let me go do this. That's going to give us a net charge of +1. So therefore, that won't work. One iron and one oxide will not balance each other out. So let's go ahead then. If that doesn't work, well, let's go ahead and let's consider what's going to happen here. Okay, how do we get it to balance out so that we have equal a net charge of 0? Okay, I'm going to go ahead and do this to the side here really quickly. All right, so let's go ahead and do this. Right now, iron has a greater charge. So if we had 2 oxides, we have 4- and a 3+. That's not going to, that's still not equal. So let's go ahead and what if we had 2 irons and 2 oxides? Okay, that still is not going to be equal because now we have 6 positives and only 4 negatives. So let's add another oxide. So if you notice, I'm just going back and forth until we get to the point now where the charges are the same. They do balance. Okay, so if we have 2 irons here, it gives us a net charge of 6+. If we have 3 oxides here, it gives us a net charge of 6-, and 6 positives and 6 negatives will give us a net charge of 0. So going back to what we have over here, that means then we need to have 2 of these iron atoms and 3 of these oxygen atoms to get us a net charge of 0. Okay, hopefully you can see that. Okay, so that's the math that we have to do, and so therefore we can write this out. Okay, we need 2 irons, so we'll write that now as a subscript, and we need 3 oxygens. We'll write that as a subscript. Okay, and again, if you notice in our final formula, I have left out the charges, so that's the formula for iron 3 oxide. Now, if you notice, if we would have just from the very beginning just moved this number down to here and this number down to there, we get exactly that formula right there. So that's our crisscross method that I'm going to continue to work with, and I'm going to use primarily starting tomorrow. But like I said, please do make sure then that you understand how we did this here. So what we did on the side here, please make sure you can follow that as well, because that is actually what you should be doing. And when we crisscross the charges, that is actually what we are doing. Okay? We're just doing it a little bit faster. Okay? All right, very good, folks. Let me go ahead and save this for you. Please make sure then that if there's any part of this that you do not understand, please stick around after I take roll tomorrow and ask about this. Okay, and so practice this. Make sure you get your questions answered. Okay, and then because moving on, this is a very important skill that you have to be able to do. Okay, all right, very good, folks. Have a good rest of your morning. Have a good rest of your day, and I will see you folks tomorrow when we take roll in class. Okay, I'll see you then.